Hello, geometry. So today we're going to talk about triangle congruence theorems, specifically SSS and SAS. Previously, we learned that to prove triangles are congruent, all 6 corresponding parts must be congruent to each other. The 6 parts are the 3 angles must be congruent to another set of 3 angles, and the 3 sides from one triangle must be congruent to the other 3 sides of another triangle. And if all that's true, then you can say that the 2 triangles are congruent to each other. However, it is possible to prove triangles are congruent using fewer parts. So the side, the SSS congruence, says that if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent to each other. A way that we might use that is in a proof like this. Well, let me go back a little bit. So let me give you an example. You got a triangle like this, and you got another triangle. If this one is congruent to that side, and this side is congruent to that side, and this side is congruent to that side, then you can say that this triangle would say something like ABC is congruent to triangle DEF. And you would write your triangle congruence statement. Triangle ABC is congruent to triangle DEF. Excuse the softness. And so the goal is to prove that all 3 sides are congruent to all 3 sides here. And then you can say the 2 triangles are congruent. So that's what we're going to try to do in this proof. Okay, given the fact that segment AB is congruent to segment CD, and B is the midpoint of segment AC, you're going to try and prove that this is a true statement. Okay, so we generally do 2 columns proofs. And over here you have the statements. This is the reasons. So our goal is to prove that each side of this triangle, ABD, is congruent to each side of that one. So let's start with the side that we already know. AD is congruent to CD. It says so in the given. So you'd write down AD is congruent to CD. Given. Then we could say DB is congruent to itself. DB. And maybe you remember this one, maybe you don't. This one was reflexive property. Reflexive property of congruence, not property of equality. Okay, so we got 2 of them. This is a side, this is another side. We're trying to go for a third side. Well, then that would be this side is congruent to this side. Well, what's the reason that's true? That AB, sorry about that. What's the reason that AB is congruent to CB? Well, if B is the midpoint, then that means that it creates 2 equal segments. And so the definition of a midpoint, if you recall, we talked about this before, definition of a midpoint is the reason that we know that this segment is the same as that segment. So we've done each part, and now we can say triangle ABD. Remember that the order of the letters matters, is congruent to triangle C. C matches up with A. B matches up with itself, and D. And the reason for all of this is the side congruence theorem. Sorry about my little line there, but you got to prove each part, and then you can say the whole triangle is congruent to the whole triangle. The same is true for the side angle side congruence theorem. The only thing we should know about this one, though, it's a little bit different, is that there's something called the included angle. The included angle is in the middle of the 2 sides. Okay, so I'll expand on this in a second. But if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. So here's a picture. If we say, for example, this side and that side. So say, for example, AB is congruent to XY, and angle B is congruent to angle Y, and BC is congruent to YZ. That means 2 sides and the included angle, the angle that's in the middle of the 2 sides, or another way to think of it is where these 2 sides meet. That angle is the included angle, and it has to be in the middle of the 2 sides. So side, angle, side, matches up with this side, angle, side, and therefore we can say that the triangle A, B, C, we have to match up the letters, is congruent to A, B, C. A matches up with X, so we'll say X. Y matches up with B, I'll say y, and z matches up with c. So ABC is congruent to XYZ. We have proven the side, we have proven the angle, we have proven the side. We're going to do the same idea in this proof. So when we do proofs, we have to prove each part is true before we make a congruent statement. You have your statements over here. Your reasons or justifications are on this side. Okay, so we got to prove each part. Our goal is eventually to do something with a side, an angle, and a side. What we do know is AB is congruent to CD. AB is congruent to C. Actually, that should be, sorry, that should be CB. CB. Okay? So AB, let me write that down, is congruent to CB. Well, how do we know that? It was told to us. It's given. It's given to you. Merry Christmas. BD bisects angle ABC. Angle ABC. We're talking about this angle right here. Angle ABC gets bisected. And if you recall from before, when things are bisected, it creates two equal angles. So this angle right here and this one right here are the same thing. So angle ABD, that's the left side over here, ABD, B being the middle letter, the angle, is congruent to angle CBD. And how do we know they're congruent? Well, the definition of an angle bisector. When angles are bisected, it creates two equal angles, just like the definition of a midpoint creates two equal segments. Similar idea. So we've done two of them, side, angle, and if you recall, this angle has to be included, it has to be in the middle. So if it's side angle, then that means this is the other side we're looking for. Okay, so BD, well, BD is congruent to itself, BD, and just like we did on the other one, that is a reflexive property of congruence. So now you said each one, and you can write your congruent statement, this part at the end. You're proving it to be true that triangle ABD is congruent to triangle CBD. The reason is we have done side, angle, side. We're proving each part of that. And that's all. Hope you understand it. Watch a few times if you need to.